In this module, we're going to take a look at how to integrate multimedia content into your web pages, into your websites. What we want to do is we want to show you how to link images in an HTML page using a tag called the image tag. We've seen previously how to create some very simple HTML content, but we have not really looked deeply at how to integrate multimedia content into your web pages. We'll also have to learn a bit more about how the different image file formats, including GIF, JPEG, TIFF, PNG, and so on, affect the performance of your website and also the overall vibrancy of the images that you display. That means we have to take a look at how color works on a screen and how we can use that to better understand different image formats. We'll also have to learn how to use custom red, green, blue specified colors. We'll also take a look at how to render text in non-standard fonts and how to embed videos and audio streams into your presentations and into your pages. Let's start out by first looking at images and particularly where you can get images from. So images are essentially graphics elements that can enhance your website because they help you deliver a visual message. In fact, often your websites are much easier to navigate if you have more images because they increase white space and also call to action. They make the website more personal and overall improve just the look and feel of your website a bit. Now, of course, that means you need to understand how to use photos, images, and so on creatively on your website. That often falls more into the domain of user experience design and overall media design. So we're not going to dive deeply into that area, but things like tilting or bordering your images can give some enhanced white space. You might be able to use things like dithering and make it into black and white images to kind of improve the aesthetics of them. But we're not going to go too deeply into the design aspects. We're going to stick to the technical aspects of embedding images into your website. Now, to get images into your web page, you have two overall choices. You can create your own images, or you can grab an image from some other source. If you create your own images, you can take them with your digital camera. You can scan images or photos with a scanner, or you can perhaps hand draw an illustration. Just watch out, we'll talk more about this a little bit later on, that digital cameras can take images at a relatively high resolution, which are great for printing on photo paper, but are way overkill and way too much data for the web. It would basically make your images just way too big, and they would never be displayable on a typical screen. Just consider, for example, that a typical web camera takes pictures at a resolution of about 2000 by 1000 pixels, which is often far in excess of the resolution you have available on a typical monitor. In fact, 1.2 megapixels is just fine for the web. It's not enough for photo printing, but relatively low-grain images are more than enough for displaying on the web. So here's an example of the different types of images you might have on a web page. You can have hand-drawn illustrations, you can take photos with a digital camera, or you can scan images from a catalog using a scanner. Of course, a large part of the images that we use on our websites come directly from the web. We use the images from other sources, and that's perfectly fine on this, with the caveat that many images are actually copyrighted. So it's very important that you observe any kind of copyright. Otherwise, you might be subject to monetary fines. You could actually, quite frankly, even go to prison for that, although that's very unlikely that you're going to be prosecuted. The most that's going to happen is that you're going to owe somebody some money. But don't take it lightly. Depending on whose image you steal, the consequences could be quite severe. You might be better off, if you're going to use an image and you really like it, to see if you can't purchase a license for the image. But in that case, you need to be aware of the license restrictions. For example, some licensees might only give you the ability or the permission to print the image on printed communication like a flyer. Others might give you a license to put it up on the web, but you can't put it up as a logo on a t-shirt or a coffee mug or anything like that. So be very careful that you read the license restrictions that come along with the license you purchase. There is a type of license that is very commonly used now on the web called the Creative Commons license type that provides a bit more flexibility. We'll talk about that in a second. Another thing that is often of concern is that when you license an image, you often are given the image at various sizes and resolutions. Pick the right image size and resolution. For example, don't pick a 3000 by 2000 pixel image to put on as a small thumbprint or thumbnail of 200 by 300 pixels on your website, because in that case you are wasting a tremendous amount of bandwidth downloading that very large image from the web server to the client, and the browser then scales the image to be smaller, which means it's going to look fine, but you've wasted a lot of time and network bandwidth downloading an image and then losing the majority of the content on the browser. So the Creative Commons license is one of the most common public copyright licenses that allow relatively free distribution of copyrighted work. A Creative Commons license is a free use of a work. It basically means that if somebody publishes a presentation, a website, an image, a photo, a song, whatever creative work it might be, under the Creative Commons license type, it means that anyone can use the work and in their particular environment. Now there might be some restrictions. For example, some authors might restrict you to only use the image or the song or whatever it is in non-commercial work. That means you can't resell it in any way. Others might have other restrictions on it. So be very careful again that you are aware of the licensed restrictions. Now, if you have printed images of some sort, printed photographs, illustrations, and so on, one approach to get them into a web presentable format is to scan the image. You can either use a flatbed, a sheet fed, or a drum scanner for that purpose. Now, most scanners scan images at 72 dots per inch. That's a relatively low resolution, but it's perfectly fine for presenting that image on the web. It's a little bit fine, coarsely grained, I should say, but it's typically fine for most images that you want to display on a web page. If you need high resolution, for example, if you have a high resolution monitor, high resolution website, or you want to print it as art on advertising, flyers, and so on, then you might have to go up to 150 dpi. Now, most scanners also scan illustrations at 256 colors. That means your image will be represented with at most 256 distinct colors. Sometimes you can get more colors, but it's typically not worth it. Also, most scanners save the file in a file format called TIFF, which is a tagged image file format, because it is a non-lossy compression, which means when the file is compressed, data is compressed, you don't lose any content. So to understand this whole notion about screen resolution and compression, so we first have to understand how pictures and images are really represented on a computer screen. Your entire computer is actually made up of a series of small dots. Each line of dots is called a scan line. Each dot itself is called a pixel. Pixel is actually a short term for picture element. It was coined in the 80s, and the short version of that is now called a pixel. So a pixel is a single dot on your screen. Each line on your screen is called a scan line. Your screen has a certain number of scan lines and a certain number of pixels per scan line. That makes up the height and the width of the screen. So a typical screen that you look at today is commonly at 2048 pixels per scan line and 1920 scan lines. Now, if you take a picture with a camera, your phone camera, digital camera, and so on, it is very likely that the picture is taken at a much higher resolution, meaning many more pixels per scan line and many more scan lines that can fit on a typical screen. The reason is that most photos are often printed, and printers can render many more pixels per line and many more lines. That makes the picture a lot sharper. Now, what do you do if you have a very large image that you've taken with your camera and you want to display it on your screen? Well, in that case, the image has to be scaled. Now, the scaling is done by the browser. So if you send down a much larger image than can be displayed, the browser is the one who's going to throw out some of the pixels to kind of squash the image to fit the size. By the way, that's the alternative as well. If you send down a picture that's too small, was taken, let's say, at a resolution of 100 by 100 pixels, but you displayed it on a web page where you give the image 500 by 500 pixels room, well, it's going to scale it up. It's going to duplicate certain pixels. It's going to make the image appear very grainy and not very sharp, but at least it's going to fill all the available space. The other thing to keep in mind is that every dot that's being displayed is or needs to be of a certain color. Now, color is represented on screens by using RGB triples. So every individual dot on the screen, every pixel, is represented by the color of the dot. And the color of the dot is a number that consists of three parts: a red part, a green part, and a blue part. And it tells you, or it tells the monitor, how much intensity or how much red, how much green, and how much blue it should use. And when those three colors get mixed together in our eyes, they form a particular color. Now, we typically allocate 8 bits of information for red, for green, and for blue. 8 bits per color allow you to specify 256 different shades of red, green, and blue. If you combine all of the different shades, you get 2 to the power of 24 different colors. That's because 8 bits per color, it's 3 channels, red, green, and blue. 8 times 3 is 24. So it gives you approximately, when you convert that to a regular number, about 16.7 million different colors. And that's sufficient to render all colors that we can actually perceive. And 24 bits per color is often referred to as a true color image. Now, that also means that for every pixel we use 3 bytes. 1 byte is equal to 8 bits. So if you have 8 bits per color, that's really 1 byte per color. So you need 3 bytes per pixel. 1 byte for red, 1 byte for green, 1 byte for blue. So that basically means that every dot takes up 3 bytes. Well, if you got a pretty large image, you can do the math. It comes out to quite a bit of storage. So how exactly are images, scan lines, pixels, and colors then represented? Well, that is dependent on the image file format that you use to store your image. There are today about 5 common image file formats in use: JPEG, GIF, PNG, TIFF, and EPS. Let's talk about the most commonly used ones. All of them in some way compress your image. That basically means that instead of storing everything fully, they figure out ways of only storing parts of it and compressing the image. So instead of your file taking up, let's say, 1 megabyte of storage, 1 million bytes of storage, it might have to compress, only take up 500 kilobytes of storage, basically half of it. So it results in 50% compression. All your phone cameras, all your digital cameras generally compress images. That helps you reduce storage space and also reduces network download time. Think about it. You take a lot, if you download a lot fewer bytes of your network connection, it's going to go a lot faster. Also keep in mind that many of your users will be running over metered connections. Metered means that they pay by data. They pay by gigabyte or whatever it is. We often think of internet data being unlimited, but that's not quite the case. If you have, Comcast at home, yes, they're going to generally provide you with an unlimited connection, although many of them today, even Comcast gives you a limited number of gigabytes per month, but it's typically relatively high. Where we really run into the issue is with mobile networks. A typical data plan for a mobile phone might only allow you to have 2 gigabytes, 4 gigabytes, 8 gigabytes per month. So if you have a lot of very large images you download, you can very quickly use up all that network capacity. And of course, it's not the user who chooses, it's the web designer who chooses. So if people visit your site and the site's very heavy, meaning it contains a lot of very big images that have to be downloaded and then reduced or scaled on your browser, well, it's going to make your site appear very bloated, very slow, and it also is going to chew up a lot of the user's bandwidth. They can't tell that, but it's just not very nice. So that means ultimately we have to compress our images as much as we can. There are two types of compressions that we can employ. They're often referred to as lossless and lossy. So lossless means that the original image pixels are retained in some fashion, meaning when you compress the image, you get a reduced version of it. When you uncompress the image before you display it, you get exactly the same image back as it was before. Nothing is lost. That's in contrast to lossy compression, which looks through your image and basically looks for pixels that you really don't need, where basically your eye can't tell the difference whether they're there or not. It basically means it won't affect the perceived image quality very much, but it results in much better compression. Now, JPEG is probably the most commonly known lossy compression file format, meaning when you compress an image with JPEG, you save a lot of storage, the image is reduced dramatically, but you lose quality. Some of the original data is lost. In contrast, GIF, PNG, and TIFF use or employ lossless compression. That means the image quality is retained in full, however you don't achieve as high compression ratios. So let's take a closer look at some of the file formats. GIF stands for Graphics Interchange Format, is one of the earliest compressed image file formats. Now it only allows you to use 256 colors. In fact, it only uses 8 bits for all 3 colors. So red, green, and blue are all represented with just 8 bits together. That typically means we take 3 bits for red, 3 bits for green, and 2 bits for blue, because we can't see blue as well as we can see the other channels. So that means that there's a lot less color vibrancy. We can see, as humans, we can see about 16 million colors. So if you only have 256 colors on an image, it means that the image is not as color vibrant. It's not what's called photoreal. But GIF does have a couple of big advantages. One, it allows for animated GIFs. An animated GIF is a GIF that changes over time. Let me give you an example of that. Here's an example of an animated GIF. Now it looks like this thing is running, is real, it's live. It's not really real or live. Actually what happens is that this one GIF file contains multiple files. Each one is called a frame. And the browser knows how to display each frame after a certain delay. This delay is also programmed inside the GIF file. So basically, to create an animated GIF, you create multiple individual GIFs called frames. You then use a GIF animator, which will combine all the individual GIFs into a single GIF with a time delay in between. When the browser sees an animated GIF, it automatically goes and displays each of the frame with the appropriate delay. That's how you get this pseudo animation from an animated GIF. So the ability to have animated GIFs or animated images is one of the key reasons why GIF, even though it's very old, is still with us. Another benefit of GIF is the notion of interlacing. Interlacing allows you to have an image more quickly be viewable. Interlacing basically means that when an image is downloaded, the browser actually downloads first every other, or renders actually first every other line. So basically every odd line first, and then only after it's displayed all the odd lines would it add all the even lines. It basically means that the image is displayed in a rough format twice as fast than if every line was first rendered. The reason behind that is that imagine you have a very large website. You display potentially hundreds of images. The user might look at the page, click on a link, and go to another page without actually looking at all the images. So that basically means there is a lot of time potentially wasted by rendering all the images rather than rendering them at a higher or lower resolution. only display all the every other line before the user makes a choice and moves on. And there's really no reason to actually display all the images because they're not going to use them anyway. GIF also allows you to have a separate background, which allows you to then blend the image into the background of your page. But the big disadvantage is only 256 colors, so lower color vibrancy, and compression is lossless. No quality is lost, but it means the compression is not as strong, and that basically means that large files still take up quite a bit of room, particularly when you compare it to other file formats like PNG or JPEG. Let's talk a bit about PNG. So PNG is a more recent file format. It's actually intended to eventually, hopefully, replace PNG. PNG also allows you to have multiple frames. It allows you to have a background. It also has the ability to embed text within images that are not displayed, but it makes the images searchable and indexable by a search engine. So you can actually tag images with the content. PNG also has the benefit of allowing you to have 8 bits per pixel, so you get the full 16.7 million different colors. You have full photorealistic color rendering. Again, it is a lossless compression like GIF, but the compression is better, so it results in smaller files than GIF. TIFF is also very popular, particularly among graphic designers. It is the largest of the file formats, meaning that its compression is the least aggressive. It is also lossless, but it's by far the highest quality. Now here's an example actually, just to sort of show you what the difference is between the two. Look on the left side is a TIFF image, the right side is JPEG. If you look very closely at the image on the left, you'll see actually the individual shading of the color. You see that the outline of the mouth is a lot stronger. You see the eyebrows a lot strong. You see the freckles of the child a lot better. Whereas on the right, with the JPEG image, because of the compression being lossy, you actually lose information. So that gives you a very clear view of one's lossless, one's lossy. Lossy is not as detailed, not as sharp. It's a little bit blurry. But the benefit is that it allows you to save memory, both in memory, on disk, and download time and download bandwidth. Here's just an example. Let's say you would take TIFF as the baseline. And I actually did this. I grabbed the Northeastern logo at a resolution of 80 by 76 pixels. So it's basically 80 pixels per scan line and 76 scan lines. So let's say, TIFF, the original TIFF was 14.5 kilobytes. Then I grabbed the PNG. It's just as sharp as TIFF, but it has lossless compression like GIF, but a little bit better. So that resulted in 11.3 kilobytes, about 78% of the TIFF. JPEG is the most aggressive, but notice also the most blurry. And with that, we resulted in 4.8 kilobytes, so it's about 34% of the original TIFF. And then notice GIF, and the GIF is kind of interesting when you look at it very carefully. You see kind of weird dots appearing. And that's because GIF only uses 256 colors, so you get a lot less color vibrancy. It looks grainier. But it has by far the best compression overall, because not only does it compress reasonably well, but it just simply throws out a lot of color. So basically, because you're only using 8 bits per pixel instead of 24, you're using a 1/3 less the amount of memory because you just have fewer colors that you store. So you kind of have to decide, do you want full color, in which case you need to use either TIFF, PNG, or JPEG. Then you got to ask yourself, do I want full compression? And if I want compression, am I willing to accept a degradation of quality for better compression, in which case you pick JPEG. And that's the format that virtually all of our cameras use today, except maybe very high-end cameras that are using TIFF. And you got to kind of decide, do you want to have embedded text? Do you want to be able to have animation frames, in which case you might pick PNG. But that's at the detriment of having to use more storage. So you kind of have to weigh all these different factors when deciding how to encode your images. Now remember that the scaling of images is done by your browser. You could of course pre-scale images at certain sizes you need them to be by using image processing programs like Photoshop, Paint, Picasa, and so on. Notice, by the way, if you have an image taken at a lower resolution than what you need it for, and then you eventually blow it up or you make it bigger, it becomes very, very grainy. Remember, if there's no information in your image, the browser can't manufacture it. It's just going to try its best to kind of fill in the blanks. Now, we'll often have multiple versions of images on our websites. We have thumbnails and regular pictures. Thumbnails are smaller versions of an image used for previewing. Imagine, for example, going to Amazon or going to eBay or some other shopping site. You often see very small images of the product you're buying, and you really don't get the full images until you click on that thumbnail. The thumbnail is just a very small image. But a good thumbnail should be a smaller version of the image that's created by an image processing program and stored separately on the server. So you'll have basically a small version image and a high resolution image. Why? Well, think about it. You download the thumbnail first. You really don't need to download the full image until the user clicks on the thumbnail and wants to see the entire product. So there's no reason to waste a lot of network bandwidth to download large images that might not be viewed. So now that we know a little bit more about how images are actually manufactured, how they are stored, how they are compressed, and what the different image file formats do, now we got to go take a look at how we embed images into our web pages. Now the embedding is done using the image tag. So what we need to do now is study the image tag and exactly what the image tag contains. Now we've seen the image tag in previous HTML explanations last week, so we're not going to go into a lot of the details. You can look that up. But one of the attributes we didn't see is the low source tag. The low source tag allows you to specify actually two sources for an image. The source tag allows you to specify the URL to the actual image. But if you also specify the low source attribute, you can actually have it point to a lower resolution version of the image, which the browser actually downloads first. So for example, you could have a very small version of an image, have that be downloaded. If the user is not going to wait around for the entire page to be loaded and not wait around until the regular source is loaded, the high resolution image is loaded, you didn't waste any time downloading images, potentially very large images, that the user might not even want to look at. So this results in fast initial display and potentially having quite a bit of saving in network transport time. Of course, the initial website is going to show up at a lower quality. You may have seen that before, where you kind of go to a website, things show up very blurry and grainy, and suddenly over time things get very clear. Well, those are websites that are well developed. They use both a low source and a high source version of an image. Let's take a few minutes and look at streaming of video and audio. So besides adding images to improve our websites, we can also add video and audio. So video is a type of animation. Now animations you can also build with a lot of other ways. You don't necessarily have to use video. In fact, we just saw a few minutes ago animated GIFs as a way of building very simple animation loops. You can also use Flash, Java applets, or Microsoft Silverstream. Although the last three are really not recommended anymore, you're much better off using animated GIFs or HTML5 mechanisms. Flash is no longer being used because it's not supported on iOS devices like iPad and iPhone. Java applets have security problems and also only have limited browser support. And Microsoft Silverstream is really limited to Windows and the Microsoft Internet Explorer browser. So you're really not going to use the last three anymore. In fact, most websites are replacing them. So the only thing that's really left to you for building very simple animation loops is an animated GIF. Unless, of course, you want to go to full video. If you do that, now you need to know how to do full video. And I'm not going to get into the technology and the insights and then all the technical details of how to make video. But what's important for us from a website design perspective is how you're going to incorporate the video and the audio into your website. So you need to distinguish between whether you want to download the audio and the video or stream it. So for now, let's just call it multimedia content. Basically, when you use downloads, it means that the medium is downloaded in full before it can be played. So if you download a file, let's say a video file, you have to download the entire video file first. Take a movie. If you go to certain websites, you can download the movie. It means you have to take half an hour, 2 hours to download the entire video. Once it's downloaded, it's stored on your hard drive, and then from there you can play it back. Now that's in contrast to streamed media, which basically starts playing right away after it's done a little bit of buffering. Netflix, Hulu, YouTube, Sling Player, pick any one of the ones. Crackle. They're all stream. They basically start playing it back as soon as possible. Now they buffer a little bit of content because there's a little bit of network delay. They can often display it faster than what you can have. In fact, video is actually quite a bit of network. It takes actually quite a bit of network bandwidth. Video, 1 second of video consists of approximately 24 frames per second. That's typical web video. Although a lot of times it's actually a lot more. We often have 30 frames per second. Although for decent websites, web streaming content, about 15 to 17 frames per second is good enough. But imagine that 2000 or 2048 scan lines, pixels per scan line, 1920 scan lines, or for typical HDP is 1080p, it's 1080 scan lines. Well, that's quite a bit of pixels for each frame. You need 24 of them for a single second of video. So a single movie can easily take 2 to 3 gigabytes after it's been compressed. So downloading is problematic if somebody doesn't want to see the entire video, because you've basically blown a whole bunch of time downloading the entire video and they're only just going to watch 2 or 3 minutes of it. So when you look at that, downloading has the disadvantage that it takes a long time to download. The content's not accessible until it's fully downloaded. You can't preview the content. It requires local storage. And then once it's locally stored, there's potentially a digital rights issue. Because how do you stop people from copying the content and sending it to others? But it does have some advantages. It basically means that the content can be accessed offline. You don't have to be connected to the internet. I often do that when I download movies. If I want to go on an airplane and I want to watch a movie while I'm in the air. And it also uses HTTP and doesn't require special media servers. So it's very easy to do. You're basically just distributing a file. Now, streaming has the benefit that you can fast forward, you can go backwards, you can pause, you don't require local storage. If you don't like it after the first couple of seconds or minutes, you can just stop it and not download the rest of it. No special browser software required, and you can much more easily enforce digital rights. But continuous streaming requires high bandwidth internet connections. Also requires a video server that knows how to download the elements piece by piece. So that's why most videos are distributed directly through a video server. Services like YouTube and others, Vidal, do all the work for you of tracking the streaming. By the way, same is true for audio. Audio is also either streamed or downloaded. Great example would be Spotify or Pandora that streams audio. Now, the only thing that you want to look for when you record audio is what kind of recording format you want, and again, what kind of compression. Now, that's typically affected by, do you want one channel or dual channels, mono versus stereo, and what kind of sampling rate do you want? Meaning, how many samples do you take per second of the audio? 8 kilohertz, meaning 8,000 samples per second, is fine for voice. 22 kilohertz for web audio is fine. 48 kilohertz is more than enough for CD quality audio. And then whenever you take a sample, how much data do you grab at that sample? 8 bits fine for voice, 6 bits decent, 128 bit is typically what we use for CD quality audio. But of course, the higher sampling rate you have, higher bit depth you have, the more bandwidth it takes to download. Now, of course, you'll also need codecs. Codecs are compression algorithms that help you encode or compress the image or the audio or the video and then decompress it on the other end. Again, remember, most compression algorithms are lossy, so quality is reduced to achieve smaller file sizes and data stream sizes. But you need to have a codec on both the server and the player that are compatible. Now, we've kind of solved that problem by uploading most of our content to common servers with common formats, places like Viddler, YouTube, and so on. So that gives us an easy way of distributing content without having to worry about serving it ourselves.